Okay, so let's get into this. There's this idea of an underworld right beneath us.
Hmm.
But we're not talking myths here, are we? This is geology.
Exactly, yeah. Pure geology. We're diving into what this new map tells us about, well, what's going on deep inside the Earth.
And the map itself comes from actual research.
Oh, yeah. It's based on a big project detailed in the journal Tectonophysics. They call it the Atlas of the Underworld.
Atlas of the Underworld. Okay.
And our mission, really, is to figure out what this atlas shows about our planet's past and, what keeps it changing.
So the core idea is these tectonic plates sliding under each other,
The subduction.
right, and sinking down.
That's the one. They call those sinking pieces slabs. And this atlas, well, it took European scientists something like 17 years to compile.
17 years. Wow.
Yeah, a huge undertaking. And what's really significant is it's like the first big global picture of the Earth's mantle structure.
The whole mantle.
Well, mapping these slabs within it, it gives us a view of how it looks now
Mhm.
and how it's evolved over, get this, the last 300 million years.
300 million. That's quite the look back.
It lets us see the ghosts of old continents, basically, how things broke apart and rearranged.
But how do you even see that deep? You can't just, drill down there.
Right, no. They use something called seismic tomography.
Okay.
Think of it like a medical scan, maybe an ultrasound or CT scan,
Yeah.
but for the whole Earth.
Using sound waves or seismic waves.
Exactly. Seismic waves from earthquakes travel through the planet, and by analyzing how they speed up or slow down.
You can figure out what they're passing through. Denser stuff, colder stuff.
Precisely. You can image these slabs because they're generally colder and denser than the surrounding mantle.
Okay, that makes sense. And a big point here is that these slabs don't just melt instantly when they go down.
Not at all. That's a really key finding, actually. They used to think they just assimilated quickly.
But they don't.
No, they can hang around for a really long time, millions, even hundreds of millions of years, and they can sink incredibly deep, maybe down to almost 3,000 kilometers.
1,860 miles. That's amazing. So they're like geological fossils down there.
Kind of, yeah.
Hmm.
Permanent scars, almost. The research points out some specific ones. Right?
Yeah, like the Bitterroot slab. That's under Western North America.
That's the one. They estimate it subducted somewhere between, say, 66 and 46 million years ago.
And what does knowing about that specific slab tell us?
Well, they think it might be linked to this period of ancient volcanic activity in the area, the Shalish-Absara Arc.
Ah, so the sinking slab could have fueled volcanoes way back then.
Could have been a major trigger, yeah. It shows this direct link between the deep mantle and surface geology, even over millions of years.
And it's not just ancient history, is it? Newer slabs are involved in building mountains we see today.
Absolutely. Think about the Andes or the Himalayas, those huge mountain ranges.
Yeah.
They're direct results of ongoing subduction, plates colliding, pushing the crust up. It's happening right now, driven by these sinking slabs.
It really changes how you picture the planet, knowing these massive surface features have roots so deep down. There's a quote from a researcher, Johnny Wu, I think. He called this atlas the Human Genome Project for Planet Earth
Yeah, I saw that, and it's a great analogy, actually.
because it's foundational.
Exactly. It provides this fundamental framework, a basis for potentially countless future discoveries about how our planet works deep down, just like the Genome Project did for biology.
And it's not finished, right? The lead author, Devon Hinsbergen, apparently compared it to those really early world maps.
Yeah, like we've drawn the continents, but there's still so much detail to fill in.
So it'll keep evolving as we learn more.
For sure, our techniques will get better, we'll gather more data. This atlas is really just the beginning. It's a dynamic picture of a dynamic planet.
Makes sense. And you can actually explore this yourself online, right?
You can. The website is atlas-of-the-underworld.org. You can, poke around the map.
We'll link that. It sounds pretty fascinating.
It really is. I think the main thing that jumps out is just how connected everything is. The surface we live on is constantly being shaped by these incredibly deep, slow processes involving ancient pieces of the planet's crust.
So the big takeaway then is Earth has this whole hidden dynamic history preserved in its mantle, an underworld that's still actively shaping things.
Pretty much, yeah. These old plates are down there influencing everything from volcanoes to mountain ranges, holding this deep planetary record.
Which leaves you thinking, doesn't it?
Definitely. It makes you wonder, how many things we see on the surface today, maybe even subtle things like landscape features or resource deposits, are actually echoes of these events happening thousands of kilometers below us millions of years ago. And what else will this atlas help us uncover about our Earth in the future?